Welcome to Get Your FRQ On. Today's video is on the AB exam, question number 5 from the year 2000. And notice that this is not a calculator active question. In the question stem, we're giving an implicitly defined function of x and y, and we are asked in part A to verify that dy dx is a given formula. So when we have to find dy dx for an implicitly defined function, we use implicit differentiation and we solve for dy dx. So we're going to differentiate both sides of the function and solve for dy dx. So we differentiate the function x times y squared minus x cubed y equals 6. Notice that we have a couple of different applications of the product rule here, so let's be careful to use that correctly. We get a derivative of y squared plus 2xy dy dx minus 3x squared y minus x cubed dy dx equals 0. We're going to collect our like terms with dy dx and move everything on to the opposite side and get a formula for dy dx. So if we group our dy dx terms, we're going to get dy dx times 2xy minus x cubed, and that will equal 3x squared y minus y squared. To solve for dy dx, we simply divide both sides of the equation by 2xy minus x cubed. And that verifies the formula for dy dx as indicated in the question stem. For part B, we are asked to write the equation of any tangent lines when x is equal to positive 1. If we require that x is equal to 1, we can substitute x equals 1 into the original equation. This will leave us with an equation in y that we will need to solve in order to match the x equals 1 with any y coordinates that may get paired with it. So if x is equal to 1, the implicitly defined function simplifies to y squared minus y minus 6 equals 0, which is equal to y minus 3 times y plus 2 is equal to 0. And the solutions to that equation are y equals 3 and y equals negative 2. What that tells us is we need to evaluate dy dx at two different points, 1, 3 and 1, negative 2, since both of these points are on the graph when x is equal to 1. So there are 2 points we have to evaluate the slope of the tangent line at, so we will do both. First of all, dy dx at the point 1, 3, if I substitute 1 in for x and 3 in for y, I get 0 over 5, so the slope of that tangent line is just 0, so that is a horizontal tangent line. But because it goes through the point 1, 3, we know that its equation is going to be y equals 3. And if we evaluate dy dx at the point 1, negative 2, substituting 1 in for x and negative 2 in for y, we get negative 10 over negative 5, which is just positive 2. Now for the first one, normally I would suggest writing the equation of any tangent lines in point slope form, since it's probably going to be the easiest to get with the information that you're going to have. However, the first one is a horizontal tangent line, so we might just as well write y equals 3. That would be sufficient. The second one, it does have a non-zero and non-undefined slope, so the slope is 2, but we also know it has to go through the point 1, negative 2, so if we put that into point slope form, we get y plus 2 equals 2 times the group x minus 1. For part C, we are asked to find any vertical tangent lines. Well, the tangent line will be vertical if the denominator of dy dx is 0. In other words, when will the expression for dy dx be undefined? So we take the denominator of dy dx, we set it equal to 0. If we factor it, we get x times 2y minus x squared equals 0. That will equal 0 whenever x is 0 or when y is equal to 1/2 of x squared. If x is equal to 0, we can substitute 0 in for x into the original equation. 0y squared minus 0y equals 6 is never true. 0 is not equal to 6, so that is a contradiction. So if x is equal to 0, we're not going to get a vertical tangent line. So consider the possibility where y is equal to 1/2 of x squared. If we substitute y equals 1/2 x squared into the original function and simplify, we get 1/4 of x to the 5th minus 1/2 x to the 5th equals 6. If we simplify that, notice that the x to the 5ths are like terms. We get negative 1/4 x to the 5th equals 6. That is an equation we should be able to solve. Multiplying both sides by -4, we get x to the 5th equals -24. To solve that, we take the 5th root of both sides, and since the index of the root is odd, it doesn't matter that the 24 is negative. The 5th root of 24 is a real number. This is not a calculator question, so you better not write this as a decimal, otherwise they're going to know something is up. Leave this as simply the 5th root of -24.